Java Basics, a practical tutorial. What is a class and what is an object? Class is the template stored as a .class file. Object is created from the class. If we say car C is equal to new car, the keyword new is used to create an object. Car with the parenthesis is the constructor. C is the reference of car type. If no constructor is defined, the compiler provides a default one. Reference in stack stores the address of the object in heap. If we look at the object car, for example, it starts certain address, and that address is stored in the reference variable C. To create an object, so we have a main method where we make a new car, then we call a method setType, passing the argument Audi, and we are printing my car is and c.getType, so it will return whatever value we have passed. So we have the class car, which is extending vehicle, and vehicle, an abstract class, has the field type and setter and getter methods. So what happens here is, when you say set type, since C is a car, it tries to call it in car. It doesn't exist, so it calls from vehicle, set type. So in the set type, this dot type means the instance variable type, and type is a local variable. So we are passing the value Audi into the set type, which in turn assigns the value to the instance variable type. Then when we say get type, again it goes to car and it goes to vehicle and calls the method which returns the string type. Dynamic polymorphism. We have the program travel, where we are writing vehicle V is equal to new car. This is possible because vehicle is the parent of car. In the class car, we are writing public string getType and return super.getType. So what we have done here is, we have rewritten the code getType, but since type is a private member in vehicle, we need to call the getType method of the super. Super is the parent. So we are calling the public method getType, which returns type, and that in turn is returned from this method, and this is called overriding. This is dynamic polymorphism because the compiler knows it is vehicle V, and we are saying v.setType or v.getType. So here the getType is called from car, So set type is not existing in car, but get type is existing in car, so this is called. So at runtime it decides which type to be, which get type to be called. Abstract method. We have created an object of car and assigned it to a variable v of type vehicle, and we are calling a method move. So we have a method move in car, but it has to be either in vehicle because we are calling the method move from vehicle. So here we have mentioned public abstract void move. So this method is abstract. There is no definition, only the declaration. When we call move, the move from car is called, because anyway there is no definition in vehicle. Multiple inheritance. We have created an object of crane, which is again a child of vehicle, and we are trying to call the method lift, but the problem is the vehicle does not have a method called lift. Crane has a method lift, and vehicle is not having the method lift but having the method move. So here what happens is v.lift will not compile because vehicle does not have the method lift. Crane will not compile because it does not implement the abstract method move, and this is not a good idea. If we add lift in vehicle class, because all the subclasses will inherit it, and crane does not need move, so we cannot put move in vehicle because it will come to crane also. So how do we resolve this? Java does not support multiple inheritance through classes. So we cannot say crane extends vehicle extends movable. So we have an alternative called interface. So what we do is we create two interfaces, movable and liftable. We declare the method move and lift in these interfaces. Now what we do is we implement movable in car and implement liftable in crane. So we can see that car has a method move and the interface movable has the method move. Similarly, crane has the method lift, which is there in interface liftable. So now we can write movable m is equal to new car, liftable l is equal to new crane, and call the methods available in those interfaces. So m.move calls the method move in car, l.lift calls the method lift in crane. So if we run this, we can see movable M is equal to new car, liftable L is equal to new crane, and we will say Java C travel.java Java travel. If you look at car moves. If you look at crane lifts. So we are able to get the appropriate output. And the corresponding interfaces, movable and liftable. We have defined them. No, we have only declared the methods move and lift in these interfaces. The implementation is inside the class which implements the interfaces. Now let us go a step further. Instead of creating this object, let us get a third party to create it. So movable M is equal to, we create another class and call a method asking for a car. So we need to create this class. So public class and we need to have a method which has to be static, because we are directly calling this method without creating an object. So static method can be called directly without creating an instance of the class. So get instance and make it return a movable object and accept a string as parameter, say for example type. So it has to return say for example a new car. It's perfectly fine because the return type movable can refer to the object car. So before doing that, let us say if type dot equals car, return new car. So we make a check here. If the type is car, that means a request has come for a object of car, then this get instance will return a car object. And if else if it is bus, create a bus. You need one more else because it will not compile otherwise. Return null. So if it is not car or a bus, then it will return null. So here what we do is mobile factory dot get instance car. So if you compare it, there is a not compatible because this is not implementing movable. So let us implement it. So we need to override the method move in bus. So let us copy this and put it in bus, and we'll see bus moves. So Java travel car moves. We change it to bus. So we get bus moves. So we could have passed this string from the command line. So this is the first argument in args. So we need to pass car here. We can also pass bus. So dynamically we are getting different objects because of this mobile factory get instance. So this mobile factory class manufactures for us the appropriate object, and this is following a factory pattern. So this is one of the patterns in the design patterns. So a factory pattern returns an appropriate object depending on the requirement. But if we ask for a truck, it throws an exception. The reason is that we have not written anything called truck here. It is returning null, and in your travel you are calling move, which is not possible now because it is a null. M is null. So as a good programmer, we should have checked it here. If M not equal to null, and else put as system out println. So we can say guess 0 could not be created. And if you did not provide a argument in the command line, we get this exception, array index out of bound. So we need to put a check here also. If args dot length equals 0, that means there is no parameter. Inform the user that the usage is like this: Java travel and a argument vehicle type, and don't continue, just put a return here. Usage Java travel vehicle type. So the user knows how to use this.